Mr. LaBeouf here again for sixth graders to continue our discussion of integers. We're going to talk today about two topics that apply to any numbers, the related topics of comparing and ordering. The only difference between comparing and ordering is that with comparing you have only two numbers. Ordering is more than two numbers that you're asked to put in order, usually from least to greatest. Occasionally the textbooks, I'm not sure about IXL, might ask you to put some numbers in order from greatest to least. Well, it's just in the reverse order from least to greatest. Anyway, a first grader learns that 3 is less than 7. Put a big circle between two numbers. We're being asked the question, which sign do we put here? It's one of three signs for any two numbers. Either this one is less than this one is greater than that one, or they're equal. There are only always those three possibilities. And of course, 3 is less than 7. We learned that in first grade. Well, what about once we encounter fractions? And we're asked that question. How does 1/3 compare to 1/7? Well, this time 1/3, the number on the left is greater than the number on the right. 1/3 is greater than 1/7. And we should all have a picture of that in our minds as to why it's true. If you divide the distance between 0 and 1 into 3 equally sized pieces, 1/3 would be about there. But if you divide that distance into 7 equally sized pieces, the first seventh will be closer to 0. The first seventh is to the left of the 1/3. So the 1/3 is greater than the 1/7. And in a similar way, when we get to the topic of integers, and when we move on to considering, well, what if these are both negative integers? What if we have -3 and -7? Well, this time, -3 is greater than -7. Now, I want to share something that happens just about every year in my sixth grade classes when we're talking about this topic of comparing integers. And I'll ask the students to come up with a rule. And every year, at least one student will offer a two-part rule. The student will say, well, when we have positive numbers, the one that's further away from 0 is bigger. But when we have negative numbers, the one that's further away from 0 is smaller. And that's certainly true. But I'll usually then ask the students if they can come up with a simpler rule, that's not two parts, a one-part rule. And it's very simple. If you're comparing two numbers, the one on the left is smaller than the one on the right. It's as simple as that. -3 is to the right of -7. -7 would be over here somewhere off the board. -7 is to the left of -3. So -7 is smaller. -3 is bigger. Very simple to determine, to compare two numbers, whether they're both positive, both negative, one of each. The one on the left is always smaller than the one on the right. And you need to picture the number line very often. When you're dealing with math, you need to picture the number line in order to answer questions like this. Here are 5 numbers. If we are asked to put them in order from least to greatest, we just picture how they would be on the number line. One thing that might hit us right away is that the two numbers that are positive are certainly going to be to the right of the two negative numbers. All negative numbers are less than 0. All negative numbers are less than any positive number. The negative numbers are to the left of 0 and to the left of the positive numbers. So we can get started with that. We might see that portion of the answer first before we have the entire answer. And if we picture how these numbers would appear on the number line, -7 would be the furthest to the left. So that's the smallest. And then the next number would be -2. Then comes 0, 1, and 3. So you see, when we've given the answer here of putting the numbers, the integers, in order from least to greatest, it's the way they would appear on the number line. Not all of them are there. Some are skipped, but this is how the numbers appear on the number line from left to right. So comparing and ordering integers is a very, very simple task. I'd like to point out something for you now, a potential pitfall that you need to avoid. What if I ask you to identify that number? I've put a red dot halfway between the -2 and the -1. Well, a common mistake that's sometimes made when students are first learning about integers is they'll think that that number is -2.5. It's a logical mistake. Over here, when we go to the right of 2 by 1/2, we are at 2.5. But when you go 1/2 to the right from -2, you're not at -2.5, you're at -1.5. You kind of have to, in some cases, think of those negative numbers from right to left, as far as coming up with the fractions particularly. Why is this -1, and why is this point here -1.5 rather than -2.5? -2.5 is over here, halfway from the -2 to the -3. And the reason that this is -1.5 is because it's the opposite of 1.5. If we go to 1.5, that is 1.5 units to the right of 0. Well, this point here, halfway between -1 and -2, is -1.5 units away from 0 also. They are opposites of each other. They have the same absolute value, the 1.5 here and the -1.5 there. So be careful of that when you're trying to identify fractional numbers on the negative part of the number line. Be careful of that little potential problem. One more thing about the number line and comparing, ordering numbers. What I'm about to show you is something that will be valuable in the future when we're dealing with the topic of inequalities. I don't want to get into the specifics of that right now, but I want to show you something that's very, very clear, very obvious. It is a concept that will come up again in the future. And it's this. What if we take two numbers and then look at their opposites? Something very interesting happens. And a lot of times in math, to understand something fully, you have to think of all the possible cases. If we're going to consider two numbers, let's not consider 0 during this presentation. I don't think we need to. If we're going to consider two different numbers, there are three possibilities. Either they're both positive, both negative, or one of each. We're going to look at each of those three possibilities. Let's start with two positive numbers, and let's consider 2 and 4. So we're going to consider the two positive numbers, 2 and 4. And what we're going to do is we're going to take their opposites. The opposite of 2, I'll kind of hop across 0 like this. As we've seen before, 2 and -2 are opposites, so they are the same distance from 0. What I've done is I've reflected the 2 across 0 to get to -2. And I'll do the same thing with 4. I'll take a reflection of 4 across 0, and I'll hop like this all the way down here to -4. -4 and 4 are opposites. They are the same distance from 0. So to reflect 4 across 0, I've gone 4 units to the left of 0. But do you see what's happened? The opposites of these two numbers, 2 and 4, have reversed position with each other. Let me put that into algebraic symbols. We started with the numbers 2 and 4. And of course, 2 is less than 4. But then when we took the opposites of each of these numbers, we had -2 and -4. But the -2 is to the right of -4. The -2 is greater than the -4. So that's what has to go in between those two numbers in the circle when we compare them. Okay? It's a very interesting thing that the opposites of these two numbers were in reverse position from each other. And by the way, I talked earlier about that two-part test that some students come up with for comparing two numbers. If you have two positives, the one further away from zero is bigger. If you have two negatives, the one further away from zero is smaller. And then I try to refine that into the simple rule of left and right. The number on the left is smaller than the number on the right. That rule will always work. But interestingly enough, when we reflect two numbers across zero, in other words, when we take their opposites, the places where they land reverse position with each other. The 2 was to the left of 4, but now the -2 is to the right of -4. We'll consider the other two cases now. Let's consider these two negative numbers, -3 and -1. -3, of course, is to the left of -1, so -3 is less than -1. But let's take the opposites of each of these numbers. The opposite of -3 is, of course, 3. We reflect -3 across 0, go 3 units to the right of 0, and land on 3. To take the opposite of -1, to reflect it across 0, we go 1 unit to the right of 0 and land on 1. So here are the opposites of our original numbers. I'm going to put the 3 on the left because it's the opposite of the -3. I had the -3 on the left. Here's its opposite, 3. And 1 is the opposite of the -1. But now, of course, 3 is greater than 1. So once again, the two numbers, when reflected across 0, when we take the opposites of the two numbers, they reverse their relative positions. The -3 was to the left of the -1, so the -3 is smaller than -1, but the 3 is to the right of 1, so the 3 is greater than 1. And one last case. This last case is maybe the easiest. It's the case where we have one of each, one negative number and one positive number. Well, any negative number is always going to be less than any positive number. All the negatives are to the left of 0, and all the positives are to the right of 0. So we start with -3 being less than 1. But we'll take the opposites of each of these numbers. The opposite of -3 is 3. We will reflect -3 across 0 to land at 3. And then the 1, we will reflect it across 0 to land at -1. So now we started with one of each, and again we have one of each. We now have a 3 and a -1. The two numbers have reversed their relative positions. The opposite numbers that we ended up with were 3 and -1. And of course, the positive number 3 is greater than the negative number -1. So I hope you have enjoyed and learned from this presentation about comparing and ordering integers. It is as easy as left and right. Bye-bye for now.